So string tells us a little bit more, but what about the local variable name here, or say hello? Well, name turns out to be not there by default because it's just a local variable name, and when we run the program it just corresponds to some space on the stack. But say hello, functions that might be called from other C files tend to be reflected in the file still, and we can see them by using a different tool. This time I'm going to run the program nm, which gets the names of things in an executable or compiled object, and it shows us that there are things inside this compiled code that correspond to some definitions in the original program. One other thing we see is main, and we also see say hello. You'll notice that main and say hello have a T next to them. T stands for text because the old traditional name for where the code resides in an executable is called the text segment. You also see names like fgetUs and printf, which you know that our program calls, and those have a U next to them. The U means undefined. That means they need to be supplied from somewhere else. In this case, they're going to be supplied by the C library that will get linked to the executable as it is run. There's another thing that is defined here, which is mh execute header. The mh there is related to mock, as in mock O, and this is just something that goes in an executable to say start here. You also see that we reference standard in, which has turned into a reference to standard in P. That's because it's really the standard in objects that we get a pointer to in the compiled expanded code. And finally, you see stack check fail and stack check guard. These are things that were added because f stack protector was the default when compiling. If I try compiling again with f no stack protector and look at the objects, then we'll see that those go away. But for now, let's go back to having stack protection there.